Alright, welcome back to part 2 of my two-part movie. So, as you can recall from the from part 1, we actually configured the router's interface and we actually tested connectivity from PC3, which we mentioned was on the outside. And we tested that we were not able to ping the far interface of router 0 coming from the outside. Alright, but also we did not quite configure IP addresses for these PCs over here in the internal network. So to do that, I'll just, we could go ahead and just assign static IP addresses, but, why not put this little extra in there? So I'll actually use DHCP. Alright, so I go to config T, and I go in and I said IP DHCP, and you could do the question mark and you see the options that are available there to you. This is really a scaled back version of the Cisco iOS. So we will just do the exclusion, which is exclude the excluded addresses. We're excluding 10.10.10.10.1 because that's the interface that's actually assigned to the router, and we'll just go up to 10.10.10.10. Right, so what will happen is our first PC will actually be assigned .11. And then we do IP, DHCP, and pool, and we'll have to give it a name. Just say lab pool. Alright, we'll need to do now the default router, and the default router is nothing more than the IP address that is actually assigned to the interface of the router. So this will be the default gateway for the PC, and that's what we'll do. And we'll need to specify the network. So network in this case will be 10.10.10.0, and we're using it /24, so it's 255.255.255.0. And we'll just save that config. So with that done there, if we go over to our PC and we go to DHCP, it will just go out and it should find an IP address, right? Just like I told you, 10.10.10.11. That will be the first one. So we don't have to manually do the IP address. And we could just do the same thing for all our other machines. So let's just do this. And we'll see it just got another IP address, and we'll just do it for the last machine. And by the way, however many machines you add to the internal network, it will now get an IP address from our DHCP server, which is now running on the router. Alright, so using PC1, we should now be able to ping our web server. So let's take a look at this. Ping 172.31.0.100. Right? And we're able to ping it, no problems at all. Now comes the fun part. We'll start doing the NAT. Alright, so the next thing that we will need to do, let's go on this outside router. So if we go on the outside router, we could go in the command to the interface, and again we're going to go in the enabled mode, config T, and inside here I'm going to put a routing statement, and the routing statement will say, this is how you do it: IP route 172.31.0.255.255.255.0 FA0/0. So what I just did, I just told this router, which is router 2 outside, anytime any traffic that you have to go to the 172.31 network with a subnet mask of /24, drop it off to the FA00 interface. This is the interface that knows how to get to the DMZ. Alright, and we can pretty much also, we could start putting in our NAT statement. To put our NAT statement in, we're going to say IP NAT, right? And you could just do the question mark to see commands that are available to you. So we have three commands: inside, outside, and pool. All we're interested in right now is just inside, and again, source. So the inside source is 172.31.0.100, and you could do the question mark. I'm sorry, it's inside source, and you would do it's static because we're doing a static NAT, guys. So we have to specify that, right? And we are not. We could actually do by protocol, so we could just do certain ports, you know, whether it's a TCP port or UDP port. This time we're not really worried about that. We're just saying anything that's coming from the internet on an IP address of 74.125.20, and let's use 100, will be NATed to 172.31.0.100. So again, the command is IPNAT inside, and the inside source, and it's a static address. The inside source address is 172.31.0.100, and it will be anything coming from 74.125, being that that's our outside interface, 20.100 will be forwarded inside, right? And you notice there are no PCs in our network that's actually assigned the address 74.125.20.100 in any physical interface. So it's just a NAT translation that's going to be happening inside the router, right? And we could save our config there. And now we'll get on the inside router. So the inside router would be this one, and we'll go to the command prompt. And from the command prompt, we go into the config mode. And I'll just need to put a routing statement in there. So I'm saying IP route 0.0.0.0 0.0.0.0 FA01. So what I just did, if you just follow the mouse in the canvas for a minute there, on this router I'm saying anything that you don't have a specific route for, regardless of whatever the subnet mask is, drop it off to interface FA01. It will know how to get there, right? This route is essential because if we don't put this statement in, what will happen, anything coming from PC3, which is our internet PC, will be able to get to the inside router to FA1, and it will also get to our web server, which is located in our DMZ. However, when the web server drops it back off to its default gateway, which is on router 0, router 0 will not know what to do with it because router 0 would not know how to get to 74.125.20/0 network. All right, so that's why it's important for us to do it. So now that we have done that, I'd say we saved our config. So we made these two configs, put it in the NAT statements on the router 2, and also we put the routing statement on router 2, and we put the default routing statement on router 0 to go back to the internet. So let's go on our internet PC and let's see whether or not we can communicate to our inside network. So what we could do, we could actually try pinging. So if we do ping 74.125.20.100, let's see if we could get a reply. All right, so we're just there waiting a little bit, see what's going to happen. All right, for some strange reason, it's not working. All right, so, and this is what networking is all about. Okay, now we see that it came online. All right, so it just took a little time, you know, for everything to come online. So even though, guys, as you see, and that's why I love doing these videos this way. I like to do it in a live network. I really don't like to pre-stage anything, you know, I want you to see, because, you know, I went ahead of myself just now and said that it was failing, but, you know, it takes a little time, I guess, for the settings to take effect for us to start seeing the packets. All right, so we could see in our network that we have here 174.125.20.100. There's nothing assigned on any physical interface with the .100 address, but the key is the statement, this NAT statement here that we put on our router. We're saying this router knows how to get to the 172.31.0.100 network. The external interface of router 2, which is the internet face inside of that router, doesn't. On the internet, we know that RF1980 addresses, which is the private class, is 10.0.0.0/8, 172.16.0.0/12, and 192.168, /24. Those addresses are not routable on the internet. So in order for anyone to be able to reach those addresses which are on our network, what they have to do is that has to be translated. So the translation is happening right here. It's happening on router 2. And this is a statement that actually took care of that. So we're saying IP NAT, the inside source address, that's where the files are stored for a web browser. It's 172.31.0.100, and anything that's coming from a routable internet IP address, which is 74.125.20.100, should be forwarded over here. And this statement is the one that does the trick. Of course, as I explained to you guys before, if you look at this config that I have further up, which is the IP routing statement, we had to put that statement in there because router 2 still needed to know how to get to the internal network, right? And if you notice, the internal network is not locally connected to router 2. It is actually on router 0. That's why we put that statement in there. And over on router 0, we had to put a statement to tell it how to get back. Notice we put a default statement because we don't know the network on the internet where this traffic is going to come from. And we need to be able to get back to whatever network it comes from. And that's why we put the default route 0.0.0. And we don't care about the subnet mask either. But all we know is, FA01 is the interface that could get us back to where we're coming from. And just to do a little bit more tests here, we could go back over to PC3. And going over to PC3 here, we could actually go to a browser. And if we went to a browser, we could test to see whether or not. By the way, if you don't know, Packet Tracer actually has a built-in web server. You could take a look at it. These are the services that are available to you for testing. We have HTTP, DHCP, TFTP, DNS, and all that, those goodies that are available in there. So we could actually go back to the internet or internet-facing PC, and if we typed this IP address, 74.125.20.10, we should be able to see the browser. All right, so let's try that again. We should go to the browser, and if we type, again, 74.125.20.100, which is the IP that's NATed over to 172.31.100, we should be able to see the browser. And there you go, right? So we know that we can successfully get in from the... All right, so we see that NAT, it fully works, guys. We also... want to look from the internal network and to see whether or not we could get to the web server. Notice from the internal network, if we decided to type 74.125.20.100, let's see what happens. I can tell you that it won't work. All right, you see request timed out because internal network doesn't know anything about that IP. However, if we did the 172.31.0.100, we should get our web page. Okay, so as you see, coming from the internet, we have to use the public IP address. Coming from the inside, we have to use the private address. I hope this was very informative for you, and I hope you will come back to see more of my videos. I want to thank you very much for taking the time out to look at this. And please leave your comments. And if there's anything that I could do to improve the quality or the way in which I explain anything on any of my videos, please don't hesitate to drop a comment and let me know about it. Again, thank you very much. And I do hope this was very informative for you. And I hope to see you next time. Thanks.